Hello, my name is Hamzito and this is a video tutorial on Sympy, which is a Python library for symbolic mathematics, and many projects use Sympy. So I'm going to show us the basics of Sympy, and the first class on Sympy which we have to know is what is symbolic computation, and that is what we are going to stay and focus on today. So symbolic computation actually deals with computation of symbols in mathematics directly. And so if we're going to start with symbol in mathematics, let's start with something as simple as square root. So if we're going to start, we'll start off the Python. Then now the Python is running on Anaconda. So let's say we want to try something like square root. We'll import math. Then we've imported once you import math, then we say square root math. Let's say 16, and it gives us our answer 4. Okay, let's say we want to find a square root of a number that does not have an exact square root. So let's do it, and we'll put math dot squared of, let's say, 15. You see, it's in form of a decimal number, you understand, and the actual square root of this thing cannot actually be in form of decimal number, because it's an irrational number. So indirectly, let's see another method of finding out the square root. Like mathematically, you get that, like square root of 6 or square root of this. So mathematically, let's try another different method with Sympy. So now we are going to import Sympy. Import Sympy. So now the Sympy is running. Then we start. Then now we're going to try another method of finding the square root with Sympy. Of 16. You see, the square root gives us 4. So now let's try the square root of 15 that we did with Sympy again. So we're going to try the square root with Sympy again. So now we have you see, instead of giving us the decimal, it gives us square root of this thing. So if we want to find out where the real power of symbolic computation actually lies, so now let's try another different let's try something different, like square root of 8. So we'll now go like this, or let's say the same square root of 15. Sympy, or let's say 8. Let's use 8. Sympy sym sympy.st. You see, it gives us 2 multiplied by the square root of 2. You get 2 multiplied by the square root of 2, and that is actually the real square root of 8. So now let's go with a much more interesting example. You understand? And this one is a much more complicated one that has real symbols inside. So if we if we want to define a math, let me open my notepad so that I would actually write it for you to understand. Okay, if we want to stay and get let's say we have x plus 2y, you understand? So we want to stay and find out, like this is Now we want to find out, we want to use symbolic computation for this one. So how are we going to first write it in Python? So we will now you guys were now trying to input symbols into Python. So you now go from Sympy, import symbols. Then in the next place, that's where we now get to import our variables, which are the symbols. So we will now put x comma y is equal to symbols bracket so right now we are trying to give each values, we are trying to set the variables into Sympy. So once we now press enter, we get, so we will now stay and give the expression, the value. So once we now put expr is equal to x plus, we've already inputted the symbols already. So right now I'm trying to put in the equation. So x plus plus 2, that's our equation that we have on our notepad, x plus 2y. I'm trying to put it into this. So x plus 2 multiplied by y, you get. So once I press enter, we've already put it already. So once we put the expr, now our equation is now, it has now given us the answer, which is x plus 2. Our equation is now inside. So we should, now that we wrote it, cool, no x and y, they are normally normal variables, so let's just stay and play around with it. So once we now put expr plus 1, you see our expr, we've already defined the value of expr. So now that I put expr plus 1, it has added 1 to our previous equation. So now if I want to subtract, if I want to remove the x code, I'll now put expr minus x. So we now have 2y, that's 2 multiplied by y. So if you notice, cool, when we type expr minus y, cool, we just got once put the expr minus x, cool, we only got 2 minus y, because expr, we've already defined expr already. You get, cool. So once we now put, we have our expr already set. So once we now put x multiplied by expr, it now gives us x multiplied by bracket x plus 2y already. So we normally we are expecting it to be x squared plus 2xy, but it actually gives us the answer in Sympy. So now we're going to stay and try another different, we're going to stay and try another different method. You get, cool. So if we're going to stay and try another different method, or when we stay and going to try another different method, we can see, okay, from Sympy import expand so expanded. because we're trying to like expand our calculation, you get. So x multiplied by expr. So expr you see, now that I've already expanded it, so it's no more outside the bracket. The x has already multiplied all through into the bracket. So if I want to remove x out of the bracket, all I need to do is to type in factor, then bracket, expanded. You see, now the x is out of the bracket. So now let's go to the real part of symbolic, the real power of symbolic computation. And the power of symbolic computation is actually the ability to do different kind of computation symbolically, and we can do stuff like derivatives, integrals, limits. We can solve different kind of equations, matrix, plenty kind of things. So now let me just give you a small example of this thing of symbolic computation before we actually go to the next complex ones later. So now we'll start with from Sympy import, because we are going to put in a new variable now. So from Sympy import, so this time now we are going to introduce 3 values. So when we are going to introduce new 3 values, we'll introduce value x, then we introduce t, then we introduce z. So now we are going to actually give we are going to stay and input the variables into Sympy. So we give them symbols x and nu. These are the four variables in which I included right now. These are the 4 variables in which I included right now, and I'm trying to actually input them into Sympy. So with this right now, the variables are included in Sympy already. So in case we want to stay and like print if you want to print it out so that it will come out in a very nicer form then we give it init. Like we want to use Unicode because we're going to be using a lot of Unicode characters. So now we're going to put use Unicode. So now let's say we want to find something complex like derivative. Let's say we want to find something like as complex as the derivative of sine x I want to find the derivative of sine x e. Want to find the derivative of sine x e with exponential of x. Okay, want to find the derivative of sine x e. So this is how we'll start with it. We'll first start with differentiate, then we'll give the first bracket, then sine x. You know, we've already given each variables. We've already given 4 variables into the system: x, t, z, and nu. So we'll differentiate sine x, then multiplied by exponential, then we have x, then comma x. You understand? So we're trying to find the differentiation of sine x multiplied by exponential of x. You understand? So clicking on this, we already have sine, we already have we already have the answer. E is sine x, e sine x plus e cos x. That's our answer already. So let's say we want to find something like something complex like integration. Let's do integration now. Want to find like integration, want to compute the integration of sine x dx, sine x squared dx. So we'll now go to integrate, then bracket sine, then bracket x then bracket close, then comma, then we have bracket open, then we have x, comma, then we have minus oo. That is infinity. You see, this is for integration where we have, so when we are trying to integrate sine x squared dx, then we now have the answer to be root 2 multiplied by root of pi divided by 2. That is the answer of that. So let's say we want to do limits. Limit of x to 0 sine x all over the x. Then we'll do something like this: limit of bracket sine bracket x bracket closed divided by x, then comma, then we give x, and comma, then we have 0. That's what we're trying to find: limit of x to 0 multiplied by sine x all over x. Then our answer, okay, I guess we had an error at that. Let's do it again. We have limits of sine x, I forgot to put the last bracket, so now we'll put it in, divided by x, comma, x, comma, 0, then we'll put the bracket outside. There is definitely a bracket. Okay, so practically this is just an introduction to Sympy, and Sympy is actually completely open source and it uses Python, and many algebra system actually use Sympy. So, and this comes to the end of my tutorial on Python Sympy. Thank you.